All right. So once you have this data entered into your the spreadsheet on your calculator, what you can now do is instead of plotting the points, what we want to do is we want to find the line that shows the best fit. So we're going to go to this F5 Calculate tab right here, and we're going to select the type of calculation we're looking to do, and that is linear regression. So linear regression is abbreviated LIN. So if we click over to the right, it's the fifth one down. Okay? It's not LN. So LIN is linear regression, meaning we anticipate it's going to be a straight line. The LN stands for a natural log regression. So it's something completely different. So you do need to make sure that you have the right regression equation selected here. So we're going to choose linear regression. Okay, and then in the X and the Y, we're going to fill out the corresponding columns. Remember, X was our column 1, C1. Y was our column 2, so we're going to enter that in those spots. So if we select C1 for our X coordinate, C2 for our Y coordinate. Now the next thing it asks is, do you want to store the regression equation? Okay. What this means is, do you want the calculator to save it in the Y editor? And we do. That way you can reference it or use it later on. So we are going to select one of these. So I'm going to select Y1 of X to start with. You can choose any of them. Okay? If you want to keep them and not write over the top of them or overwrite them, you can use a new one each time. Just make sure you're organized with that. And once you hit enter, it's going to give you a little table. Here's what the table represents. On the top of the table, it gives you the general form of your equation. So we chose a linear regression. So the general form is y equals ax plus b. It's the slope-intercept form of a linear equation. Okay, now below that, it tells you what the specific values of a and b are. It tells you that a is a value of 5.5, b is a value of 17.3. And then below that, it gives you what's called correlation coefficient, and that value is 0.992967. Okay, so here's how you interpret this, and then the r-squared value you don't need to worry about. Okay. The way that you interpret this is the solution or the line of best fit is simply going to be these variables plugged, or these numbers plugged in for the variables a and b. So our answer for this is y is equal to 5.5x plus 17.3. This is the equation of our line of best fit for this data set. And now this value right here is the correlation coefficient. And the correlation coefficient basically states how likely is it that that data is actually fits well on the line. Okay, so this is going to tell us how well that data fits on the given line, and it's basically probability or percentage. Okay, so it fits with a probability of about 99%. So the closer it is to 1, the more accurate or the more consistently it's going to fall on that given line. So you want these correlations to be close to 1. Right? There's a couple other things that this correlation coefficient will do. If it's positive, your graph will rise. And if it's negative, your graph will fall. And this data will be somewhere between -1 and 1. The closer it is to those extremes, the 1 and the -1, the more likely it will fit, or the better it fits on the given set of data. So you want the correlation coefficient to be either high point 80s. It's kind of like a percentage. So this would be about 99%. You want it up in the 90%, or at least the high 80s. And if it says a negative 0.99, that just means that it's a 99% correlation or a high correlation. The negative simply indicates that the graph is falling. It means it has a negative correlation. As the x's increase, the y's decrease. And now you should be able to see those correlations on your own. So what happens here? As the x's increase, what's happening to our y's? Are they increasing or decreasing? When you look at this, just this data set. As x's get bigger, y's also get bigger. So that's a positive correlation. Okay, so step one, you're going to enter your data. And so you'll do that by, again, going to your data matrix editor, hit the apps button if you need to, select data matrix editor, just edit your current one. My x's are already the same, so I'm just going to change my corresponding y. So I enter 20, 13, 11, 8, and 7. Now, what I should notice here is, as my x's increase, what's happening to my y's? Are they going up or down? They're decreasing. So if there is a correlation here, the correlation is going to be a negative correlation. And so let's test it and see. So once we enter our data, what we're then going to do is evaluate it using our F5 calculate command. So if we go to F5, make sure you use linear regression, LIN. Okay, again, not the natural log. We want the number 5. Choose C1 and C2 as our columns for X and for Y. Now, I'm going to put this in the Y2 form of my Y editor. So when I write store to, now I'm going to put it in the Y2 of X form. That way I can still keep my original equation in case I need to use it for something or refer back to it. When I hit enter, I get my answer. My equation that models this data is negative 3.1 plus 21.1. My correlation coefficient is negative 0.949 approximately. Okay, so it's relatively close to -1. That tells me I have a negative correlation. And because it's close to that -1, it's a high correlation. So this equation is pretty consistent with the data set that's provided here. Okay? Now,